Geometry, Unit 4, Lesson 3. What do you know about an isosceles triangle? Most students will tell me that an isosceles triangle has two congruent sides, and they'd be correct. So let's draw a picture and label its features. So an isosceles triangle has two congruent sides called legs. And its base is a different length. These angles down here at the bottom are referred to as the base angles. And the angle up at the top is referred to as the vertex angle. Couple of theorems about isosceles triangles. First one says if two sides of a triangle are congruent, then the angles opposite those sides are also congruent. So the idea of what does it mean to be opposite? I have two pictures here from the photo scavenger hunt, and a side opposite an angle, one student said was the leg of a triangle that is not connected to the vertex. And this was the whole point of animating or annotating the slide. So if this is the vertex here, opposite is directly across. It's the one that's not making up that corner. Another student put that it's the side of a shape opposite or across from a certain point. So the vertex is highlighted in blue and the opposite side is highlighted in blue as well. So going back to those theorems, if two sides of a triangle are congruent, then the opposite angles are congruent. So it's basically saying if sides are congruent, then the base angles are congruent. Which is why it's marking angle A and angle B congruent, because if the sides were marked, which they were, then you could show that the angles are. Converse, flipping it around, if two angles of a triangle are congruent, then the opposite sides of those angles are also congruent. So in this particular picture, what was marked were the angles. So if base angles, then what can you conclude? Then the sides are congruent. So the order of the if-then statement depends on what the diagram marked first. And then the last one, it's a little bit harder. And what it says is the bisector of the vertex angle of an isosceles triangle is the perpendicular bisector of the base. We've constructed all of this, and if we had class time, we would. Maybe we will. But the idea of it is if you think about a triangle, we already discussed that the top one up here is the vertex angle. So if you were to cut that vertex angle in half, this half and that half, so they're marked congruent, which they are in the original diagram. What that means then is the angle bisector also is creating a perpendicular bisector of the base. So we've constructed both perpendicular bisectors and angle bisectors. So a couple for you to try. The first one has marked sides. If sides are congruent, then I can understand that the base angles are congruent. I'm going to use the big triangle here to recognize that both of the base angles are 63, but I don't know what the vertex angle is. Grab your calculator and you can figure out that the vertex angle ends up equaling 54, but the original problem isn't asking me for just the whole vertex, it's asking me for a part of it. Both of those are marked identical, so that must be an angle bisector. So half of 54 is 27. So this angle is 27 degrees. Bottom two, explain why each statement is true. So it's giving you statement A, and it's asking for you to explain why is it true. Looking at the diagram, I noticed that WV and line segment WS are marked congruent. So the statement I'm going to give is if sides are congruent, then base angles are congruent. And I'm going to go ahead and mark those angles. One of them is, but I'm going to mark the other one. Letter B is giving you a statement. TR, line segment TR is congruent to line TS. How can you conclude that? Well, using the statement that I just made over here, I was able to mark angle S congruent. Angle S has the same marking as angle WBS, so all three of those angles are congruent. It works out that since those bottom two are base angles, then that means that the sides must also be congruent. So my second reasoning is going to say that if base angles are congruent, then sides are congruent. Handful that you have to set up and solve for x. Look at the markings that it gave you. It's giving you that these base angles are congruent. If base angles are congruent, then side lengths are equal. Go ahead and solve it. Letter B, it's giving you side lengths. Even though there are two angles there, be cautious before you set them automatically equal to each other. We have to think about the idea of opposite. The angle opposite the side length is here. The angle opposite the other side length is way over here. So if we know that if sides are congruent, then angles are congruent, then that one is equal to 3x. I'm going to recognize that because I have a triangle, all three angles can be added up to 180. Go ahead and solve. Letter C, in this particular example, the angles are all marked congruent. So if angles are congruent, then sides are congruent. So it means that all three of these are equal to each other. And that leads right into the next problem. Go ahead and solve it, or the next one. There's something called the equilateral corollary and equiangular corollary. The triangle, isosceles triangle theorem said that if sides were congruent, then we knew that angles were congruent. The same thing can be true for an equilateral triangle. If you recognize that the sides, that it's equilateral, so if the sides are congruent, then we can recognize that all of the angles are congruent as well. Same concept, just being applied from an isosceles to an equilateral. Same thing goes for the converse of the isosceles triangle theorem. It said that if you knew the angles were congruent, then we knew that the sides were congruent. Same thing can be true for an equiangular triangle. If you know that all of the angles are congruent, then you can recognize that the sides are congruent. So the idea of if sides, then angles. And over here we have if angles, then sides. So the theorem works for equiangular, equilateral, and isosceles triangles. That concludes lesson 3 of unit 4.